Now, I showed you the leap to get from here, right? But I also showed you why it was right to be suspicious and think differentiation was worthwhile because of this n minus 1, okay? So now, looking at this question, what do you think we should do? It's n plus 1 and it's division rather than multiplication, so this looks like integration to me, okay? So, just like before, let's start with this identity, okay? 1 plus x to the n. Okay? And let's integrate both sides with respect to x. Okay? So I'm going to be a bit lazy. I'm just going to slap it in this first line. Okay, so, by the way, don't forget your dx's, okay? You have to integrate with respect to something. So, again, chain rule here, right? Because the derivative of the inside is 1, that's why it's easier to handle, okay? So what happens? I raise the power up. And then, of course, I have to divide by the power that I just got, so that if I differentiate, I'll get back to where I came from, okay? All right, now that's equal to, it's just the x to the r that I'm integrating, right? So you've got this, and I'm going to raise the power and divide by that power, okay? But I'm missing something, right? I integrated, and it's an indefinite integral, okay? So I need a constant flying around. Now remember, because I've integrated both sides, I don't need two constants, okay? Because if I've got a constant here, got a constant there, take the difference of two constants is still constant, okay? So I'm just going to slap the constant on one side, okay? Okay, constant's there. So now what? What do we usually do to get rid of a constant? We usually have like initial conditions or some point that the primitive function passes through, and you sub it in, and then that'll let you find C, right? Except I don't really have any initial conditions or anything like that, right? What else could I possibly do here to work out what C is? Now, even though I don't have initial conditions, I do have some conditions, right? Because this x which I introduced, yeah, it's going to be equal to something later on in order to fit with what I was required to prove, right? So what value of x should I pick here that's going to make this line look most like what I'm required to prove? X equals 1. In fact, very frequently it's going to be x equals 1. Okay, so I'll say let x equal to 1, right? Therefore, what am I going to get on the left-hand side? I've got 2 to the n plus 1 on n plus 1, right? Plus my constant. Now, what happens over here on the right-hand side? You're going to get this sum. Okay? All right, but hold on a second. Some of these things are equal, like this thing and this thing, they're both constants, aren't they? Aren't they? So this constant here should be equal to this sum. That's just, well, look carefully at it. The top part is just the 1, right? So that's 1 over r plus 1. Is that okay? Right? Minus this. Now, I'm going to pause there. I think I've held your hand enough. Think about where you've got to end up, okay? I'm pretty close, right? Look at what I've got over here. That's basically this, okay? What do I need? Is it that minus 1? How do I get it in position, okay? So, I'm going to give you a couple minutes. Have a think.